Ta-da! Emission Spectra. My name is Muhammad Latifudin bin Amran. You can call me Din.
My name is Nur Ahmad Hani. You can call me Hani.
My name is Muhammad Aiman bin Rozalan. You can call me Aiman.
My name is Nurani Zati. You can call me Zati. Hello. Now I'm going to tell to you what is it the emission spectrum. So let's go. Emission spectrum is a spectrum of the electromagnetic radiation emitted by a source. Either continuous spectra or line spectra of radiation is emitted by substance. The emission spectrum of a substance can be seen by energizing a sample of material either with the thermal energy or with some other form of energy, for example, a high voltage electrical discharge. This is the diagram that shows how emission spectra happen.
My name is Aiman. I'm going to explain to you about this thing.
If you want to know, every elements have a different types of emission spectra. For the first third row, it is for the alkali metals, and then followed by alkaline earth elements, metals, and end with gases. For example, at the first row in the diagram, which is lithium, it has its own emission spectra.
Hi, I'm going to explain to you about formula how to calculate the energy of photon. So let me start. Energy photon, which is energy from light, is equal to data energy. To calculate data energy is like this. Final energy equal to Rydberg constants multiply with 1 over principal quantum number of final. Same goes to the initial energies. From that questions, we can conclude that delta energy is equal to Rydberg constant multiply with 1 over principal quantum number of initial minus 2 1 over principal quantum numbers of final. So that's it, the formula to calculate the energy of photon. Thank you.
My name is Farah, and now I will explain to you about the Bohr model of the atom. So let's start.
Bohr model description of the structure of atoms, especially that of hydrogen. The Bohr model of the atom, a radical departure from earlier classical descriptions, was the first that incorporated quantum theory and was the predecessor of wholly quantum mechanical models. The Bohr model and all of its successors describe the properties of atomic electrons in terms of a set of allowed possible values. Atoms absorb or emit radiation only when the electrons abruptly jump between allowed or stationary states. Direct experimental evidence for the existence of such discrete states was obtained.
Hi, I'm Din. So now, lastly, I'm going to tell you about the examples of emission spectra question. So let's go. Okay, the question is calculate the wavelength in nanometer of photon emitted by a hydrogen atom when each electron drop from the n, or the name is principal quantum numbers, 5 state to the n, 3 state. The calculation of it is you can use the formula delta E, or the formula is RH in bracket 1 over initial n minus 1 over final n. Then from this formula you can substitute the value. RH value is 2.18 minus 10 to the power of negative 18, and then you have to multiply with 1 over initial n minus 1 over final n, and in this case the value of n is 1 over 25, that is initial n, and the value of final n is 1 over 9. And then you can use the calculator to get the answer. After that, you need to use the formula h multiplied with c over lambda. H refer to Planck constant, c refer to speed of light, but we must find the lambda. So the equation that we must use is h multiplied with c over e. E means e photon that we find yearly. So you can substitute the value. H 6.63 multiplied with 10 power of negative 24, C 3 multiplied with 10 power 8 divided by the answer that we get, and then you will get the answer. Ta-da!